Okay, in these problems we're going to add just a small degree of difficulty, and when you draw the timeline you'll see exactly what I'm talking about. So in 22 you deposit $1,000, but you don't do it today. You do that at year 6. So year 6 $1,000 goes in, and it's going to earn 10%, so R is equal to 10%. And I want to know the value 9 years from today. So this is a future value problem, where future value equals present value times 1 plus R to the t. But I would rather write it like this. I'd rather say the value at year 9, because that's the future, is equal to the value at year 6. Now yeah, 6 years in the future is the future, but in this problem, because we're looking from year 6 to year 9, 6 occurs first, so I treat that as a present value. It's all very confusing, right? So it's easier for me to have the subscripts. The value at year 9 is equal to the value at year 6 times 1 plus R to the third. Because 6 plus 3 is 9, I've gone 1, 2, 3 steps to get there. So the value at year 6 was 1,000, and the interest rate is 10%, and I go forward 3 years, and then I wind up with $1,331 exactly. Question number 23 is very similar. Repetition again is the key. So in question number 23 we're going to deposit $3,000, but we don't do that today. We do that at year 9, so $3,000 goes in the account, and it says it earns, the interest rate is 7%, and how much will it be worth at year 15? So the value at year 15 is equal to the value at year 9 times 1.07 to the 6th power, because if I count this out, 10, 11, 12, 13, 14, I'm going forward 6 years. So this money, this $3,000, earns 7% and sits in my account for 6 years. 9 plus 6 is 15. Therefore it is worth at year 15 $4,502.19. Alright, so that's the trick, or not the trick, that's the difference in these problems. And we'll continue with number 24. Number 24, you deposit $30,000. I'm going to draw this timeline. I got to see when I deposit that $30,000. It's not today. I deposit $30,000 in year 2. And it's going to earn 5%. And 10 years from today, it'll be worth what? And again, the timeline, if I see that, I know exactly what's going on here. The value at year 10 is equal to the value at year 2 times 1 plus R to the 8th, right? Because 2 plus 8 is 10. I'm going forward 8 steps. So the value at year 2 is $30,000 times 1.05 to the 8th, and that is equal to $64,307.66. Alright, so now look at number 25. And number 25 is going to start with present value type problems. So suppose you need to have $4,000 in the account, not today, but at year 10. You have $4,000 in the account at year 10. How much should I have to have in the account at year 2? And my interest rate is 10%. So now the present value is equal to the future value divided by 1 plus R to the t. The way I like to write that is the value year 2. That's my present value, even though it's 2 years in the future. The value year 10, that's my true future value here, divided by 1 plus R to the 8th. Because I'm going back 8 steps. 10 minus 8 is 2. So 4,000 divided by 1.1 to the 8th is equal to $1,866.03. Alright, and now we'll go to question number 26. And of course we'll draw a timeline. So you need to have $9,000 in the account 14 years from today. And the account pays 7%. How much must you have in the account at year 3? So year 0, year 3, that's how much, that's what I want to know, year 14, and I need to have $9,000 in this account, and my interest rate is 7%. So the value in year 3 is equal to the value in year 14 divided by 1.07 to the 11th, right? 3 plus 11 is 14. So $9,000 divided by 1.07 to the 11th is equal to $4,275.84. Let me pause here and talk just a little bit about the calculator. So the best way to do this in the calculator is to type 1.07, then y to the x, then 11, then equal, and that gives you a big long number, right? Rather than writing that number down and maybe miscopying it or rounding it off or having some trouble like that, press the 1 over x key, and that's going to take this number in the denominator, flip it over and put it in the numerator, and then you multiply by 9,000. So let me repeat that. To solve this mathematically in the calculator, the best way to do it is 1.07 y to the x, 11 equals, press the 1 over x key, and now you've taken the denominator number and you flipped it over, and now you can multiply by that, it's an ugly 9, by that 9,000 and get this answer. Okay, so let's move to question number 27. Again, draw a timeline. And 27, you need to have $50,000 in the account at year 20. So 20 years from today, I want to have $50,000 in the account. Here's today, and my account pays 5%. And you want to have how much in the account at year 7? So how much at year 7? I'm going backwards. I'm dividing. It's a present value type problem. Value at year 7 is equal to the value at year 20 divided by 1.07 to the 13th. That's the key, really, is knowing this exponent. So it's $50,000 divided by 1.05 to the 13th. So if I take my calculator and do 1.05 y to the x 13 equals, press the 1 over x key, then multiply by 50,000, hit equal, I should get $26,516.07. Alright, let's go to question number 28. Make sure we have this timeline drawn out correctly. In question number 28, you deposit $2,000 in the account, not today, but 4 years from today. And 12 years from today, the account is worth $2,800. And I don't know what the interest rate was. So what's the interest rate equal to? The way I will set this up, I'll say the value today, or the value at year 12 is the value at year 4 times 1 plus r to the 8th, right? Because I'm going 1, 2, 3, I'm going 8 forward or 8 back, however you want to look at it. So 2,800 is equal to 2,000 times 1 plus r to the 8th. So 2,800 divided by 2,000 is equal to 1 plus r to the 8th. So I take both sides and raise to the 1 over 8 power, 1 over 8. So 2,800 over 2,000 raised to the 1 over 8 is 0.125 is equal to 1 plus r. So r is equal to 2,800 over 2,000 raised to the 0.125 minus 1. So r is equal to, this is question number 28, 4.30%. Alright, we're almost there. Just a couple more questions. Let's look at question number 29 and draw that timeline. Since we solved for r before, we're going to solve for a number of years in this case. So I've solved for present value, future value, interest rate, and now solving for t. So here we are today. It says suppose you deposit $3,000 at year 5. Here's year 5. We put in $3,000. And I want to know how long it takes this to become worth $4,800, and the interest rate is 10%. So the value at year what is equal to the value at year 5 times 1.10 to the I don't know what power. But remember what we did before when we were finding time. Time is equal to the natural log of the future value, which in this case is 4,800, divided by the present value, which in this case is 3,000. Right? See, even both of these occur in the future, right? This one's first, so it's present value. That one's later, so it's future value. Divided by the natural log of 1.10. That's equal to 4.93. But that's not the answer. If it starts in year 5 and it goes 4.93, takes 4.93 years from then, it must be 9.93 years from today. So 9.93 years from today before that will be worth $4,800. Alright, our final question. Question number 30. We have a real rate of return equal to 3%. We have an inflation rate equal to 2%. And we want to know the value today. So the value right now today of receiving $20,000 at year 7. So the value today is equal to the value at year 7 divided by 1 plus r to the 7th. And here's where things can get a little confusing, because finance doesn't always have consistent terminology. The rate that I've been putting in here, even though I've used lowercase r, and that's kind of the standard way to do it, this is really the nominal rate. So I need to know the nominal rate, which is 0.03, the real rate, plus inflation 0.02, plus real times inflation, which is equal to 0.0506. So the rate I need to use is 5.06%. So the named rate, 5.06%, and all the other problems when I said the interest rate is, or the discount rate is, or the account is earned, I'm referring to the named or the nominal rate. So here V0 is equal to $20,000 divided by 1.0506 to the 7th power, because I use, like I said, the named rate, and that's equal to 14,156.90. So all I did here is combine the material from questions 18 to 21, put it in with one of the more complicated time value of money problems, and that's it for your intro to the time value of money.